Greetings and welcome, Internet friends. Me and my Algebra 2 students are going to revisit a unit that we've already done. We've already done writing equations of quadratics and parabolas, but we skipped a couple problems because we did not yet have the ability to solve a system of 3 equations and 3 variables. And so we're going to kind of merge those ideas together right now. And so this is from Algebra 2.04, Big Ideas, example 3 is where we're picking up. And so here's this first point where you can actually identify a quadratic data set if you have equally spaced x values and you take the differences between them. Okay, so from 9 and 4, there's a difference of 5 and 3 and 1 and 1. And I guess here they're doing the second, take away the first to get negatives, so 4 minus 9, etc. Or you could also say 9 take away 5 is 4 and take away 3 is 1. And notice that some of these change direction, and that's because this is a parabola, right? That it's going to be going down and then up, or up and then down. But if you then do this additional thing where you've probably done these sorts of differences before in calculating linear equations back in the day, and if there was a constant rate of change is what we said, we knew that it was linear, and you could actually use that to figure out the slope and whatnot. But here, if you now take these first differences and find their differences, so it's kind of the second difference, if that is constant, it turns out that you're going to have a quadratic. And if it's a quadratic, then we could try to predict what that equation might be. And so here's example 3. NASA can create a weightless environment by flying a plane in parabolic paths. The table shows the height h in feet of a plane t seconds after starting the flight path. After about 20.8 seconds, the passengers begin to experience weightlessness. Okay, right, and evaluate the height at which this occurs. Okay, and so here's some time, here's some height. The first thing we would have to do is determine whether or not this is a quadratic, and so we could do that with differences. And to speed this up, I'm going to just not grab a calculator. So this is 2,125, then this is 1,575, then this difference is 1025. And so far, notice this is not the same number, and so I can expect that it is not going to be linear as a result. And let's see, and so this is kind of interesting. But now if I do it again and take these differences, I get negative 550. And if I take these differences, I get negative 550. And if I take these, I get negative 550, etc. And therefore, it is a quadratic, okay, because the second differences were constant. Now, the point of all that is this, that I can now use this data to try to write a quadratic equation. And notice it says 3 points, and you might be like, there's a lot more points there than 3. I'm only going to use 3. And so I'm going to use this data point and this data point. And it doesn't matter which 3, but these ones seem friendly enough. And because I know it's a quadratic, if I use the data point 10, 2, 6, 9, hundo, what I'm going to do is plug them into the quadratic, a quadratic equation. So y equals ax squared plus bx plus c. And so if I know it's a quadratic, I know it's going to be in this form. And if I know the a, b, and c, I would know the exact quadratic that I'm talking about, right? Like just like in y equals mx plus b, if you know the m and the b, you know the line. So this time I have 3 things that I'm looking for. And if I have 3 unknowns, I'm going to need 3 clues to help me find them. So 3 separate equations. And so I'm looking for the A, B, and C. And the way I'm going to do this is plug in 10 and 2,600, 10 in for the X's and 26,900 for the Y's. And so, just to kind of speed up this video, if I do that, I would get 10 squared is 100. Sorry, 100A plus 10B plus C is equal to 26,900. And so that's one set of equations written in terms of the A, B, and C that I'm trying to solve. And now I'll do the other points. So 20 and 30,600. And then I'll do the other equation, 30 and 32,100. And so if I do those, 20 squared is 400 times A. So 400A plus 20B plus C equals 30,600. And then 30 squared is 900, so 900A plus 30B plus C equals 32,100. And so now that I have a system of equations, I can solve for A, B, and C, which are then going to give me the exact equation for this data set. And so this is entirely possible. And so let's we could use elimination method, maybe because all of the C's are the same, which they always will be in this setup, because X doesn't influence the C value. So let's figure out, and since A is the equation with all the smallest numbers, I'm going to get the opposite of A. So I'm going to figure out what's negative 1A. And so that would be negative 100, little a, minus 10b minus c equals 26900 of the negative variety. Here we go. And let's eliminate that. And so negative 1a plus b will eliminate, so this and this will eliminate a c. And negative 1a plus c will eliminate these c's. And so when I do that, I got 300a plus 10b. The c's cancel out, and this side is 3700. And I'm cheating without reaching for a calculator just to speed up the video. And then I'll combine negative 1a and Charlie. And so 900 minus 100 is 800a. I've got what? Yeah, 30 minus 10 is plus 20b equals. And if I combine those, I get 5,200. And so now this is what I typically have been labeling equations D and E. All right. I now have a system of 2, and so let's try to solve these. And so let's do elimination again. I'll do my sky blue. So between 300 and 800, 2400, I believe, is the smallest number that they both go into, I think. Yep. And between these, it's 20. And so I'll just go for the 20. I'll multiply this equation by negative 2 in order to get the 20. So negative 2d would give me minus 600a minus 20b equals negative, what's that going to be? 7,400. I believe. And now I can combine negative 2d and e. And so adding these together, I get 200a. The b's cancel out, and this is equal to negative 2,200. And so all of my system of equation work is identical to what we've been doing, and it now allows me to solve for things that I wasn't previously able to. And so I get a equals negative 11. I could then solve for b. What's an easy equation with a and b in it? I'll solve for equation D's version of it, I guess. And so I'll do this. So 300 times negative 11 plus 10b equals 3700. And hopefully this is getting more familiar for you, right? And so let's multiply this out. Let's see. Did I do that right? I think so. Some reason I've been doubting myself more lately. Made a couple mistakes in that last video. It was like the first Waddy Math video I had to edit in a while. So let's see. We'll add this to both sides. 10b equals 7,000, and then div 10, div 10. And I get b equals 700. All right, and so there's a, there's b, and now to find an equation that's going to help me solve for c, I'll plug them both in for this one. So 100a plus 10b, and so what I just got here for b, I'm going to plug in for that. I'm running out of space. Let's see, dare I try to fit it right here? Well, I can try to fit it up here. So, 100 times what would have been a, plus 10 times b, plus c equals 26900. And so a was negative 11. And b was 700. And so I get negative 1100 plus 7,000 plus c equals 26900. I get 5900 plus c equals 26900. 0. Subtract that from both sides, and I think I get 21,000. Now, this problem's so long, we got to make sure we actually know what we're doing. And so all I did was find the values of a, b, and c that make this equation match this data. And so currently the equation is y equals negative 11x squared plus 700x plus 21,000. And so this is the equation of this parabola. All right, and so once I have that equation, let's see, was that what they were looking for? They said write and evaluate the function and approximate the height when this occurs. So after about 20.8 seconds. And so I would plug in 20.8 for x. Let's see. So I would have had negative 11, 20.8 squared plus 700 times 20.8 plus 21,000. All right, and if you simplify that, you get about 30,800.96. And so this is the height in feet, is it? Yep. Of the plane at the time when the passengers begin to experience weightlessness. All right, so to run that through, I verified it was a quadratic using second differences. They were the same. I then picked 3 of the points and plugged them into the standard form of a quadratic, and then had 3 equations where I was trying to find the values of little a, b, and c. I then solved that system, in this case using elimination. I found a, b, and c, and then I wrote my equation. And then using that equation, I could make predictions. I could also, because this is a quadratic, I could calculate, the vertex of it and the maximum height that the plane was at, etc., etc. Okay. So here we go. If I was to do this here, I might just do the quick setup for this one. So the general or standard form is y equals ax squared plus bx plus c. If I was using these points, which I did notice that 0, 1, that's a y-intercept. If I had like an x-intercept, I would be able to figure out a factor of the one that works. But these are just like 3 points. Because, yeah, it doesn't always work out that easily. And so here are the 3 points that I would plug in. 2 and 7. I'd plug them in for the x's and the y's, so plugging in -1 squared is +1, so I'd have 1a, I'll tell you what, I'll write it, 1a minus 1b, oh man, plugging in for x, here we go, plus c equals 4. All right, plug in 0, 0 squared is 0 times a is still 0, so there's 0 a's, there's 0 b's, so I'd get c equals 1. Ooh, that's helpful. And then I'd plug in 2 for x. 2 squared is 4, so that's 4a plus 2b plus c equals 7. Right, the 7's the y there. I just threw it on the other side. So here, if I was to solve this, I would do substitution, because this is like already, look at that, look at that. So this top equation, I would have a minus b plus 1 equals 4, which is the same as a minus b equals 3 if I subtract 1 from both sides. This equation here, I would have had 4a plus 2b plus 1 equals 7, and then subtract that 1 from both sides, and I would have 4a plus 2b equals 6. And so here's what I typically would have called my equation D, and here's my equation E, and it's a system of equations with 2 variables and 2 unknowns, solvable using our previous strategies. You could then solve by substitution. All right, I'll do it. Well, I'm going to solve by substitution because this A looks like a nice one to solve for. So if I do a minus b equals 3, I would solve for a. I'd get a equals b plus 3. I could then substitute that into the other equation. So 4 times that plus 2b equals 6. And I've got b plus 3. And so 4b plus 12 plus 2b equals 6. Combine like terms, that's 6b plus 12 equals 6. Subtract 12 from both sides. 6b equals a -6, so therefore b equals -1. Aha! And then start backpedaling here. Substitute here. And so a equals plus 3, b is -1, and so a equals 2. And then I could plug that in to find c. And so I'm plugging. Oh, wait, I already knew what c was. And so final answer would have been, what is it? 2, -1, 1 was the ordered triple that solved the system of equations, but we wanted the equation of the parabola, and so that would have been y equals 2x squared minus x plus 1. is the equation of the parabola that passes through those 3 points. Wonderful, wonderful, wonderful. Okay, and so that's kind of the general setup. Now let me, I'm going to skip this one. You do the second differences, pick 3 points, same idea. It turns out you can also use technology. Yes, and I'm going to want you to know how to do both of these things. But you can use technology just like you did best fit lines back in the day, and whether you used a graphing calculator or Desmos or something different, you could have technology find the best fit line. Actually, even spreadsheets do it. And so here's example 4. This is vehicle fuel efficiencies at different driving speeds. Write a function and then predict the optimal driving speed. And so I've plotted that data. Boom, got it. Here's that same table. So this is using Desmos, and in Desmos, once I have a table in terms of x1, y1s or whatever, I can now make a quadratic regression. And so I'm going to do y1 tilde, which is kind of like shift and then the button right next to the 1 key. And then I'm going to write a quadratic. All right, ax1 squared plus bx1 plus c. And look at that. I get the graph. It's automatically solved for a, b, and c for me, right? So there's the values of a, b, and c. And it's even graphed that equation. Okay, and then if I wanted to say figure out the optimal driving speed, well, that's going to be the vertex, and voila. Would you look at that, folks? There is the optimal driving speed. Looks like 48.457 miles per hour. And then the optimal equation is right here. And so if I wanted to write that out, they didn't actually, they did, I guess they did say write the function. So y equals negative 0.014 x squared plus 1.36, I guess I went out to 3 decimals there, 366x minus 7.144 is the equation of that, and the optimal driving speed is 48.457 miles per hour, giving you a miles per gallon of 25.957. There. And tell you what, I've already got this other one queued up. We'll do it on this one too. This table represents the maximum weights in tons that X inches of ice can support. That's worth knowing. And so I happen to have that same table represented here. And I've got it right there. And so I would do y1 tilde ax1 squared. Make sure I square it. I forgot to do that earlier. Plus bx1 plus c. x1 plus c. So I've got to make sure I actually have it represent the data sets. And so let's see, which represented what here? So X was the thickness, Y was the weight. And so apparently 10 inches thick can't supports 0 tons. Okay. What did they want to know? How much weight can be supported by ice that is 22 inches thick? And so I could drag this until I get to like 22 and try to estimate it that way. But I could also just say, hey, X equals 22. That gives me the equation of the vertical line there, and then just click and find their intersection. And so apparently 22 inches thick of ice can support 32.36 tons of weight. Tons are 2,000 pounds each. So that's a lot of pounds right there. They wanted the model of the function. Okay, all right. I'll give it to them. And so notice when I did this, not only did it graph it, but it also gave me the values of A, B, and C down here. And R squared equals 1 means it's 100% accurate. This graph hit every single one of those points is one way that you could think about it. I'll use the purple. So Y equals 0.0 9. Oh dear. I'm gonna have to round. All right, 0.100 x squared minus 0. Yeah, I'd have to 498. Yep. When I round to 3 places. And minus 5.007. Boom. And so there's the equation. So next time you're going to drive your truck out on the ice, you got to make sure, figure out the thickness, and then you could support 32 tons. Although like a 2-ton vehicle would be down here. You'd only need like 12 or 13 inches thick ice. Boom. All right. Well, anyways, thanks for watching. Hope you have a great day. Y'all take care.